All right, so section 4.5 and 4.6 is on determinants and Kramer's rule. Okay, a determinant is a real number that's associated with the square matrix. So when we talk about these rectangular arrays of numbers, there's like one number that's associated with the matrix. There are formulas to find determinants for 3x3 and 2x2 matrices, and determinants are incredibly useful when trying to find the solution of a system of equations, as we did in chapter 3. So we've learned the graphing method, we've learned substitution method, elimination method, and now we're going to learn a new method which is called Kramer's rule. Okay. So the determinant of a 2x2 matrix is the difference of the products of the diagonals. So do you guys remember what the main diagonal was? We talked about it last time. The main diagonal, what direction does it go? From the top left to the bottom right. Okay, so do the main diagonal first when you're doing these. Okay, so your main diagonal is A times D. And then your other diagonal is C times B. So I'll write BC. So it's AD minus BC. Okay, that's going to be the determinant. Yep. Easy points. All right, so number 1. So I'm going to have 1 times 8 minus 4 times 5. So I get 8 minus 20, which is negative 12. So that is the number that's associated with that matrix. And we'll get to why these are useful in a little bit. All right, 2. So I'm going to have 1/2 times 2 minus negative 1/2 times negative 1. Be careful with your negatives. Remember, you're subtracting. Okay, so I have 1 minus negative 1/2 times negative 1 is positive 1/2. So 1 minus 1/2 is 1/2. Okay, the next one, so main diagonal, so 1/2 times 2 pi, so just pi, minus negative 1/4 times 1/4. So I have pi minus a negative 1 over 16. So it's pi plus 1 over 16, and you can leave it like that. That is a number. Okay. The coefficient matrix is a system of linear equations in standard form. So when you have a system of equations, it's the matrix formed by the coefficients of the variables. So if we had 2 equations with x and y in them, it's just the numbers in front of x and y. Okay, so the coefficient matrix in this case would be A1, B1, A2, B2. So just the numbers in front of x and y. So Kramer's rule for 2 equations, so if I wanted to solve something that has 2 equations, you can do substitution or elimination. It would actually be faster than doing Kramer's rule. But Kramer's rule is going to be really helpful later when we have something bigger than a 2x2, like a 3x3 or a 4x4 or 5x5, and we have computers to help us. So Kramer's rule can be very useful. All right, so D is going to be the determinant of your coefficient matrix. So it's going to be A1, B1, A2, B2. And notice how I just have straight lines? I should have mentioned that before. Determinants always just have straight lines. So if I was finding the determinant, I would write it 1, 5, 4, 8 with straight lines. This means determinant. Okay, so when you see the brackets or even parentheses, that's just your normal matrix. The straight lines mean take the determinant. Okay. So x is going to be something over that D that we just wrote. So the something is going to be where we replace my A1, A2 with the numbers we haven't used yet, C1, C2. Okay. This will make more sense in a second. So C1, C2, and then B1, B2 stays the same. Okay, and then Y is just like your D matrix, but instead of B1, B2, we replaced it with the C1, C2. So C1, C2, and then your first row's the same, or first column's the same. Okay, So basically, if you want to find the x value, you replace the x coefficients with C1, C2. So to find the first variable, replace the first column. To find the second variable, replace the second column. Okay. So like I said, when we do some examples, this will make more sense. Right. And then sometimes you're going to get weird things. So like the first one is, you know, if D is not equal to 0, you're not going to have anything that's undefined because D was on your denominator. So if it's not equal to 0, you're going to have one unique solution. So you're going to get an answer. But if D is equal to 0, you could have one of two things. So the first thing would be at least, D is equal to 0 and at least one of the other numerators is equal to 0. Then it has infinitely many solutions. That's because one of them would be like 0 over 0, which is like, what is that? Is it 0? Is it infinity? Undefined? So that would be infinitely many solutions. And then the other case is if D is equal to 0, and then neither numerator and the other determinant is 0. So that means you have like a number over 0 and a number over 0. Then it would be no solution. So let's try these. Okay. I always call this whole matrix, I call it D1. And I call this whole, well, not matrix, but determinant, I call this D2. So when I'm finding the first variable x, I call it D1. When I'm finding the second variable y, I call it D2. So when I start out these problems, I'm going to find D, D1, and D2. So D is just your normal coefficient matrix. It's 2, 1, 3, negative 2. Did you guys see that? So just the numbers in front of your x and y. Okay, D1 looks exactly the same, but we replaced the first column. So D1 replaced the first column. What do I replace it with? 10, 8, right? So the other column's the same as what it was before. And then D2, you keep the first column the same, and you replace the second column with the 10, 8. Okay. Then we find the determinants for each one. So you guys remember how to take the determinant. So you do your main diagonal minus the other diagonal. You're doing the products. So it's going to be negative 4 minus 3. So I get negative 7. The next one's going to be negative 20 minus 8. So negative 28. And then the last one's going to be 16 minus 30. So negative 14. So your x is whatever D1 was divided by D. So in our case, it's negative 28 over negative 7, so we get 4. And then our y is whatever D2 is divided by D. So it's negative 14 divided by negative 7, so it's 2. So that means our two lines intersected at the point 4, 2. So like I said, you guys can do substitution or elimination, which is really helpful on your test because you can check your work and see that you get the same thing. But later on, like with computers and things, this would be much easier to do when you have more than 2 variables. So if I had like 26 variables, yeah, your computer's using like determinants. So it's much easier that way. All right, so the next one. So notice how the next one isn't in that general form, like the x, the y's, and then the numbers. So you have to get it in general form first, or standard form. So get in standard form. Okay, so that means I'm going to have 3x minus 2y equals negative 5. And I'm going to have 9x minus 6y equals negative 15. Okay, can you guys tell what your answer is going to be? You guys see how those are almost exactly the same equation? Just multiply the second equation, or the first equation by 3, and you get the exact same line. So what does that mean when you have the same lines? Infinitely many solutions. Okay, so you should kind of be thinking, is this going to be one that has infinitely many? All right, so let's go ahead and do D, D1, and D2. So D, I have 3, negative 2, 9, negative 6. So I end up with negative 18 minus a negative 18. So I get 0. Okay, so that's your first clue that something's weird. Because when you find x, it's d1 over d, so you have 0 in the denominator. Okay, so it's either a no solution or an infinitely many solutions. All right, so if we get that neither d1 or d2 is equal to 0, then it's no solution. If you get that one of those other ones is 0, at least one of them, I mean both could be. If you get at least one of them is equal to 0, then it's infinitely many. All right, so d1 is replace the first column with negative 5 and negative 15. So when you do that, you get 30 minus 30, so you also get 0. Okay, so you don't even have to find d2 now. So this is no solution, or it's infinitely many solutions, sorry. Which we knew because we knew they were the same line. Okay, next one. So I'm going to subtract the 2y over. So I subtracted it over to the other side. So I get 6x minus 2y equals negative 4. And then I have 3x minus y equals 7. So can you tell in this one what this is going to be? If I multiply my second equation by 2, you'd have 6x minus 2y equals 14, right? Is that the same line? No. These are different lines, but they have the same slope. So this is going to be a no solution one. So let's go ahead and see what happens if we tried Kramer's rule. So d would be 6, negative 2, 3, negative 1. And if you had, if you had switched it the other way and you had negative 6x plus 2y equals 4, that would be fine. Like you might get different d values, like you might get the opposite value, but it will work out being the same answers in the end. Like x and y will end up being the same. Okay, so I get negative 6 minus a negative 6, so I get 0. d1, replace the first column with negative 4, 7. So I get 4 minus a negative 14, so I get 18. And then d2, replace the second column with negative 4, 7. First column still 6, 3 like it was for d. So I get 42 minus a negative 12. So I get 54. Okay, so the only thing that was equal to 0 in this case was d. So when that happens, it's no solution. Okay, you guys go ahead and try 4. So try 4. So find d, d1, and d2. Okay, so some of you guys are getting d2 is equal to 0, but d is equal to 0 is the one that's either no solution or infinitely many. So if d2 is equal to 0, what does that mean about y? Y would be 0, right? Yeah. So you guys see it? Okay, so let's go ahead and solve it. So if I have d d is going to be 4, negative 5, negative 8, 2. So I get 8 minus 40. So you should get negative 32. d1, replace that first column with the other numbers, 3, negative 6. So 3, negative 6. And then my second column is the same as what it was before. So I get 6 minus 30. So negative 24. And then d2, replace the second column with the 3, negative 6. The first column was the same as what it was before with d. So I get negative 24 minus negative 24. So that makes plus plus, so I get 0. Okay, so remember x is d1 over d, which in our case is going to be a fraction, negative 24 over negative 32. Both are divisible by 8. So you get negative 3 over negative 4, so 3/4. Okay, then y is d2 over d, which I can see right away is 0 over negative 32, so it's 0. So your answer is 3/4, comma, 0. Fractions and 0, man, that was a tough one. Okay, so it says obviously it's just as easy to solve these systems using substitution or elimination. Some students like using Kramer's rule if the solutions are fractions. So like that last example, your solutions were fractions. So if you tried substitution or elimination, you would end up working with fractions with it adding and subtracting things. And some people don't like that. So some people think it's easier just to use Kramer's rule. It's also really easy to do this without having a calculator. I mean, these are all basic things you can do without a calculator. You can also use Kramer's rule with the 3x3 system, but first we need to learn how to take the determinant of a 3x3 matrix. All right, really, I mean, people don't really do this by hand with a 3x3 system. Like, there are ways to find the determinant on a calculator, but we're going to learn the by hand method, so you guys are going to do it, and then I'll show you how to use the calculator later on. So you got to learn by hand first. Okay, so it says the determinant of a 3x3 matrix is found by a lattice method. Do you guys know what a lattice fence is? Have you guys heard of that? Lattice fence. What's it look like, Andrew?
Isn't it, it's composed of a bunch of different kind of squares and...
Yeah, but they're like squares on the side. It's like diamonds, kind of. So it's a bunch of like straight lines that go this way, and then a bunch of straight lines that go this way. Okay, that's what makes a lattice fence. Have you guys seen those? Okay. All right, so this is going to be a lattice method. So we're going to be doing like downwards diagonals, upwards diagonals. Okay, so it says first, rewrite the first two columns at the right side of the determinant. So if I'm taking the determinant, I'm going to have A1, A2, A3, B1, B2, B3, C1, C2, C3, and I write my straight lines to mean that I'm taking the determinant. Or you could just write DET out front. It doesn't matter. And then I'm going to tack on the first two columns again on the side. Okay. Okay. Then we do the product of the downwards diagonals. And there's going to be 3 downwards diagonals. Do you guys see where they are? Like that. So what you're finding here is, and it's very weird when it's written out with letters, so don't freak out, it's going to be A1, B2, C3. You're going to add on B1, C2, A3, and add on C1, A2, B3. So that's the sum of the downwards. And then you subtract out the sum of the upwards. So see where your upwards diagonals are? So right there, there, and there. So you're going to have A3B2C1 plus B3C2A1 plus C3A2B1. Okay. If you guys memorize this, I will hurt you. Do not memorize this. That would be ridiculous. You're just going to know the method. Okay. So if I want to find the determinants of the following matrices, so for this first matrix, I have 2, 5, 1, 4, 0, negative 4. So I tack on the first two columns. And a lot of people like to do sum of downwards. They like to find that first and then find the sum of upwards. So down and then up. And remember, you can always remember what goes first because the downwards one is your main diagonal. So always remember, main diagonal goes first, just like with your normal 2x2 matrix, or 2x2 determinant, right? You went downwards minus upwards. All right, so the first one, I'm going to have 2 times 0 times 8. See how this is going to be easy if you have a lot of zeros? The next one's going to be 4 times 3 times 1. And the last one's going to be negative 1 times 5 times negative 4. So you get 0 plus 12 plus 20. So I get 32. Okay, now find the sum of the upwards diagonals. So I have 1 times 0 times negative 1. I have 4 times 3 times 2. Oh, negative 4 times 3 times 2, right? And 8 times 5 times 4. So when I do that one, I get 0 minus 24 plus 160. So I get 136. So the last step is your determinant is 32 minus 136. So negative 104. So your answer is negative 104. Okay, does it make sense? All right, let's see the next one. Okay, so first step, tack on the 2, 5, 10, negative 3, 1, 3. See if you guys can do some of it in your head. So we're going to do downwards first. So I'm going to have that, that, and that. So can you guys do some of this multiplication in your head without like writing out every single thing? So 2 times 1 times negative 1. So I get negative 2. Negative 3 times negative 2 is 6 times 10, 60. 4 times 5 times 3, another 60. So your downwards diagonals have a sum of 120 minus 2, so 118. Upwards, 10 times 1 times 4, 40. 3 times negative 2 times 2, so negative 6 times 2, so negative 12. Negative 1 times 5 times negative 3, so 15. So negative 12 plus 15 is 3 plus 40, so 43. So your determinant is whatever 118 is minus 43. So you should get 75. So 75 is your answer. Okay, does that make sense? Okay, so if you guys are wanting to start your homework tonight, Kramer's rule for 3 equations is just like Kramer's rule for 2. Only now when you do your x, y, and z, it's going to be d1. You're still going to have d1 over d, d2 over d, and d3 over d. But what do you think is going to happen? So like in order to find d1, how do you find d1, you think? How would I find it? How'd you do it for Kramer's rule with 2 equations? Replace the first column, right? So instead of the first column, I'm going to have d1, d2, d3, and then I'm going to have my b1, b2, b3 that I had for d, c1, c2, c3. So you replace first column. Okay, so y is going to be with d2, and d2 you're going to place that second column with d1, d2, d3. So the first column is going to be a1, a2, a3. And the third one's d1, d2, d3. Or not d1, whoops. C's. c1, c2, c3.
Did you tag it on at the end again?
Mm-hmm. Yep. So you have 4 determinants you need to find.
Wait, so
Mean.
What do you add on?
yeah, which 2 do you add on at the end then?
Oh, so if I was finding the first one, I would tack on those at the end.
Oh, just
If I'm finding the second one, tack on those. Does that make sense? So you have 4 different determinants. All right, so this last one, so I'm going to have d1, d2, d3. So luckily you guys only have one of these, I think, on your homework. Because they take a little bit. So that's called d3. and we'll try the example next time.